Let's see the if statement, which is a selection control structure that allows us to make decisions based on whether a condition is true or false. Specifically, we're going to analyze simple decision, double decision, and how to define the logical conditions, 3 or more ways to define the if statement conditions. If you already know how to define an if statement, maybe you'll find something new in this last part. To illustrate, I'm going to use C# language in Unity, but the concepts we're going to see apply to practically any programming language. You just have to change the syntax, that is, the way you write the code lines. In Unity, I'm going to create a script called if and assign it to the camera. That way, when we enter the play mode, the script will be executed. Let's start with the simple decision. To define the if statement, we have to write if and between parentheses put a condition that results in a logical value. For example, I can define a Boolean variable called state, initialize it as true, and put this variable inside these parentheses. Then open and close curly brackets, and inside this region will be all the code that will be executed if the condition is true. In this case, if the state variable is true. I'm just gonna print the state variable is true in the console. If we enter the play mode, we'll see this message in the console. Now, if we set the state variable to false and enter the play mode again, the message won't appear on the console. This indicates us that the program flow is not going inside that if statement, because the condition is false. Now we'll see how to make a double decision. This means that we will also perform an action in case the condition is false. To do this, we simply add else to the previous structure and open and close curly brackets. Inside those brackets, we write all the code that we want to execute if the condition is false. In this case, what I'm gonna do is simply print the state variable is false on the console. Here we see the results with the state variable in the two states. Nice! Now let's see how else we can express the if statement condition. In this case, we use a Boolean variable, but we can also use a logical expression that when evaluated will give a true or false result, and use that expression as a condition. Imagine the following example. We can be hungry or not, and if we are hungry, there are 2 ways to eat. One is being at home and having food, or we can be inside the store and have money. This last sentence can be directly translated into a logical expression that determines whether we will eat or not. Here is that expression, and to make it, I defined variables that tell us if we are hungry, if we are inside the house, if we have food, if we are inside the store, and if we have money. Notice that in the expression, we have the hunger variable connected to a much larger expression, in which we evaluate if we are inside the house, the store, if we have food. Those 2 expressions are connected through the AND operator, and it will be true only if both expressions are true. Here we have something called short-circuit evaluation. As in this case, we are trying to establish if we are eating or not. The most important thing would be if we are hungry or not, because if we are not hungry, we will not eat, no matter what the other conditions are. If we are not hungry, it's not necessary to know if we are inside the house, the store, or if we have food, for example. That's why we put the hunger variable first. If you define these variables as public, a few checkboxes will appear in the inspector to indicate whether the variables are true or false, and you can try different cases and see what the result of this expression is. This expression can also be analyzed with a truth table. In this case, we will have 32 possible combinations, and with the help of the table, we can determine when the conditions for the expression to be true are met. Another interesting way to define a condition for an if statement is to use a method that returns a Boolean value. For example, here the should we eat method will check whether we should eat and will return true or false. In this case, I make it return the result of the evaluation of the same logical expression that we had analyzed before. Then, the execution of should we eat will give us a true or false result, and consequently, we can use it as a condition for the if statement. We can also create logical expressions with other types of variables, not necessarily the logical ones. For example, floats, integers, characters, and also with strings. For example, we could use the comparison operators to ask if 2 values are equal, if one value is greater than the other, if it is greater or equal, if 2 characters match, if 2 strings are equal. Here I'm going to define 2 integers, one for the money we currently have and another for the cost of the food. And in this if statement, what I'm doing is asking if the money we have is greater than or equal to the cost of the food. If that expression is true, we buy the food. If it's false, we cannot buy it. We can also combine this way of creating an expression with the previous form using methods. If we have a method that returns an integer value or a real value, a float, we can compare the result of the execution of that method with another value and thus obtain a logical expression whose result is gonna be true or false. For example, here I define a method called how much money do I have, which will return the money we currently have. Then in the condition we execute that method and the result will be compared with the cost of the food, and thus we obtain a logical expression that we can use as a condition. This is the end of the video. Hope you find it useful. In the description I'm gonna leave you an article where you can find more information and download this same script so you can try it out. See you next time.